Good morning. I'm Lauren McPhillips, and I'm a hydrologist and biogeochemist who is fascinated by urban and peri-urban landscapes. I hope to convince you today that more of us need to be working in these sorts of landscapes. At this point in time, we've already crossed a threshold where more than 50% of the global population is living in urban areas, with an even higher proportion in the United States. Beyond the highest density areas, a lot of land has gradually morphed into exurban or peri-urban mixed landscapes of buildings, roads, and fragmented forests or fields. In the United States, this sort of development occupies roughly 15 times as much area as high-density urban. Though the most urbanized landscapes are covered by large swaths of impervious surface, even these moderately developed landscapes that comprise a sizable chunk of our land cover have manipulated hydrology. Hydrologists do have a history of interest in urbanizing areas, but the nature of our work could evolve and expand. Traditionally, a lot of the focus has been on streams and rivers in developed areas, characterizing their flashiness, investigating water quality impacts. I believe, though, that hydrologists could play a larger role in influencing how these urban landscapes are organized and managed, particularly in the redesign of existing developed areas or in newly urbanizing regions. There's a great quote from civil engineer and hydrologist Richard McCune, who advocates that smart growth strategies respect the natural hydrologic processes. In other words, where we can, developing land in such a way that is sensitive to the hydrologic and also biogeochemical processes occurring in the landscape. One example of research in this realm is a recent study focusing on watersheds with traditional end-of-pipe stormwater management practices versus dispersed BMPs. This work confirmed that the smart growth strategy of placing BMPs around the watershed yields higher base flows and less frequent floods compared to the end-of-pipe strategy that detains runoff just before it hits the stream. When it comes to envisioning how we could better respect the natural hydrology in how we choose to develop watersheds, we need to understand how water is redistributed around the landscape as a result of various manipulations. If we want to consider the biogeochemical implications of different development plans, such as how routing water in a certain way might impact carbon cycling, we need to hone fully distributed hydrologic models that can capture the complex nature of these landscapes. In this study, a distributed model helped shed light on areas of this peri-urban watershed that were particularly sensitive to phosphorus loss. Until now, I've been talking about the watershed scale, but in order to understand what's going on there, there's also a need for site-level hydrologic investigation of stormwater management practices. In this example, hydrologists right here in San Francisco investigated hydrologic dynamics in infiltration trenches and found significant groundwater recharge occurring from these BMPs. Another common feature in peri-urban landscapes is road ditches. These sorts of structures are built for a singular purpose of routing water off roads, but some of the work in our research group shows that they can have big implications for distribution of water around the landscape and biogeochemical cycling. So as the population continues to increase, urban and peri-urban environments will be an increasingly dominant land type, and hydrologists can provide valuable insight into how we manage these developed landscapes. This includes studying site-level phenomena or management practices as well as large-scale hydrologic patterns. As we embark on this work in these incredibly complex systems with the goal of achieving smart growth and sustainable, resilient urban development, it will be essential that we engage with fields beyond our own. Urban ecologists have been pretty forward-thinking in these sorts of interdisciplinary collaborations, and the long-term ecological research sites in Baltimore, Maryland, and Phoenix, Arizona are great examples in which hydrologists are involved. So while great progress is being made, and I also want to mention that it was great to see a quasi-cyber seminar on this topic this fall, there's still lots more to do and understand in urbanizing landscapes, and so I hope to see you out there.